As we move into chapter 8, we're looking at data that may not be so linear, right? We've looked at a lot of residual plots that were randomly scattered with no pattern, but now we have residual plots that may be curved and show a pattern. And so as we looked at the homework last night, number 3 was the one that was the hardest. I think a lot of people missed it because the way they worded B was really confusing, right? Even for me, I had to read it like a million times. So we have the United Nations Development Program uses a Human Development Index in an attempt to summarize in one number the progress in health, education, and economics of a country. In 2018, the HDI was as high as 0.95 for Norway and as low as 0.38 for Niger. The gross national income per capita, by contrast, is often used to summarize the overall economic strength of a country. Is the HDI related to the GNI? Here is a scatter plot of gross national index and your HDI. So explain why fitting a linear model to these data might be misleading. Well, it's pretty clear that this data is not linear, right? It definitely is not straight. Okay, everybody agree with that? Yeah. So the data appear to be not linear, and I think everybody probably got that part right. And then I answered the question, and then it took me like 15 tries to get this picture back up. So I finally just took it out of the book. But then the next question says, if a linear model is fit to the data, what would a scatter plot of the residuals look like? So that's like, okay, if I'm trying to make a line here, it's probably going to look like this, right? So the residual plot is going to have points below, clustered over here. Then it's going to have a cluster of points above, and probably a few down below here. So if you were doing this by hand and you looked in the back of the book, the book says the residual plot would show a curve. But none of these options say the residual plot is going to be curved, right? This is, let's see, the residuals will appear in a decreasing pattern. Well, what I've drawn here is not really a decreasing pattern, centered and symmetric about the horizontal axis. Residuals will appear far above and below the horizontal axis. Residuals appear in a horizontal band centered and symmetric about the horizontal axis, or the residuals will appear clustered above and below the horizontal axis. And that's the answer that's correct. Like there's a cluster below and there's a cluster above. It's not randomly scattered all the way through with consistent spread. And so this was the correct answer. But if I were asking you to describe this residual plot and you said it was curved, right? So that's why a linear model is not appropriate. That's totally acceptable. Okay. Okay, we are doing, this is number 59. I have my data about hamburgers and their fat and calorie content in my list 3 and list 4. The first thing says to create a scatter plot. Where do I go to create my scatter plot? And I'm going to go in here. I'm going to turn it on. And I'm going to go to list 3 and list 4 because that's where my data is. Now remember, I videotaped all of this Friday and posted that video. I think I put it in the module. Okay. And then we're going to zoom 9, which is stat. There is our scatter plot. Okay. How would we describe our scatter plot? As fat content increases, calories are increasing, right? There's a positive, linear, moderately strong association with the possible outliers, but it still follows the pattern. Okay, so this is not going to be, thinking about chapter 8, that point's not going to be high leverage, right? Because it's not going to change the model. It might change or increase our correlation, strengthen the model, but it's not really going to change the equation by taking it out. And so, yeah.
Would that be like the extrapolation?
Extrapolation is where we try to predict what's happening outside the scope of our data. If our data goes from 19 fat grams to 43 fat grams, we don't want to use our model to predict the calories of a burger that has 60 fat grams because our model doesn't go up that high. Okay, that's extrapolation.
Okay.
So now I need to create, in order to find R squared, I have to interpret, I have to do the lin reg. So edit or stat, calc, 8, tell it list 3 and list 4. I'm going to store my regression equation. That's vars, y vars, enter, and calculate. So my R squared is 0.92. Stop recording. Hold on. Trying to. There. Okay, so my R squared, this is B, is 0.923. So the difference is, this is one of our cookie cutter statements. The difference is in fat content. Explain 92.3% of the differences in calories. Okay, those are the posters, right? We should be making those flashcards, memorizing how to say these. You will have to interpret slope. You will have to interpret y-intercept. You will have to interpret r squared. And you will be typing it out. It is not going to be a multiple choice question. So you need to have those statements memorized. Okay. C says write the equation of the line of regression. That's going to be calories. That's my y variable, hat, equals the A is my slope, my y-intercept, 210.95 plus 11.06 fat. Okay. So remember that this is my y-intercept and this is my slope. Okay, my B naught and B1. D, use a residual plot to explain whether your linear model is appropriate. So now that I've done the lin reg, I cannot do a residual plot. I can't go scatter plot, residual plot. I have to go scatter plot, linear regression, lin reg, and then the residual plot because my calculator calculates a new set of residuals with every new lin reg. It's only one resid list. So now that I've done lin reg, the residuals for these set of data are in the resid list. So I can go back to my stat plot and I'm going to change my y list to resid. I go second above status list up to resid and then zoom 9 again. So there's my residual plot. Okay, on the test, you're going to take a picture of your scatter plot, and you'll take a picture of residual plot, you'll upload those to the question, and then explain why you think a linear model is appropriate. So linear model is appropriate because our scatter plot was linear. So a linear model it's not going to say use your residual plot. It's going to say is a linear model appropriate? And you're going to talk about what two graphs? Scatter plot. The scatter plot is linear. And the residual plot has no pattern. Consistent spread, and random scatter. So you talk about both the scatter plot and the residual plot. You will include both graphs. That is when it asks, is a linear model appropriate? Explain the meaning of your y-intercept of the line. Our model predicts a burger with 0 grams of fat will have approximately what? 210.95 calories. Our model predicts if x is 0, this is what y will be approximately. Okay. Yes.
So this question is basically almost everything that's going to be on the
Yeah. And the one I gave you on the worksheet. Yeah, that one. The carrots and the price of the diamond. Explain the meaning of the slope of the line. So remember, one of your free response questions will be like this. Plug the information into the calculator, get the scatter plot, get the equation, show me the model, which is what? What is the model? It is the equation, right? The model is the equation. And then so you'll write your equation. You don't have to worry about typing the hat, right? You can just write calories hat. It'll be fine. You don't have to try to put it, just write calories hat. Okay? Yeah, because it's too complicated to go into the equation editor and try to get the hat on top in Canvas. That's just a pain. So you don't have to worry about that when you're typing it. Okay, so then it says, explain the meaning of our slope. Our model predicts. For each additional gram of fat in a burger, the calories are expected to increase approximately 11.06 calories. For every one additional X, or every one unit X, it's 1 gram, right? So every 1 gram of fat we add to the burger, our model predicts there's going to be 11.06 more calories. Okay. G, a new burger containing 28 grams of fat is introduced. According to the model, the residual for the calories is positive 33. How many calories does the burger have? So 28 grams of fat, and the residual is positive 33. So how am I going to find that? What am I going to do? Residual is actual minus predicted. What I'm trying to find is the actual. How do I get predicted? Say that louder. Use my model, right? The calories hat is 210.95 plus 11.06 times the fat, 28 grams. The predicted is what we get when we plug it into the equation, the model. So that's the calories hat is 520.63. So we're going to, the 33 is equal to the actual minus the predicted 520.63. If you want to do this algebraically, you're adding 520. Right? But really, if it's positive, if the residual is positive, you add it to your actual. If it's negative, subtract it from your actual. So that's 553.63 calories in the actual burger. Okay. Questions on 59? Other questions you want me to go over? Are we good on that? So we're good on the rest of the homework?
Yes, ma'am.
Okay.
Miss Will, can
Yeah.
you scroll up a little bit, please?
Mm-hmm.
Thank you.
We're gonna do this activity called the graduating class. It's gonna review a lot of the concepts that we've already had to do practicing the calculator for tomorrow's test. I'm handing it out now. You're going to need to put the data in your calculator. Remember that if we don't want to enter in all this year, we could just enter in 50 for 1950. So we're putting this data into a new list. You're going to need to clear out all of your lists in your calculator because we're going to use all 6 lists today. Okay? So I need you to put this into list 1 and list 2.
And then we can just write like 50.
Yeah, you can just type 50.
What about for when we get to 2,000?
Say that again?
Like when we get to 2,000.
Then it's 100.
Oh.
Right? So we're going to talk years since 1900, so 2000 will be 100. Okay? So we're going to put in 50, 53, 57. This is just a time saver, really. And it also keeps our numbers a little bit smaller. Okay, then I just stopped doing that. 84. And 89, 92, 96, 98, 100. And then, so we should have 19 values in each list. So take a second and make your scatter plot.
Do we need to do the list thing for this one?
You will eventually, yeah.
Am I able to do that before doing the scatter plot?
Yeah.
Okay.
Yeah, you can do it before the scatter plot. You can also do the scatter plot first. You have to do the lin reg before the residual plot. Okay, so on the paper, you're going to describe the trends you see in the data. What do we see? Hold on, let me. if our scatter plot is showing a weird outlier, you want to investigate that. Okay, use trace, go over and find the point. It'll tell you exactly what's entered in the calculator, and make sure that that data is correct for the table. Okay, sometimes, a lot of times, really weird outliers that distort your graph are from entering it in incorrectly. Okay, so that's how you find out what the problem is. You hit trace, you find that point, and it'll tell you what the numbers were put into the calculator for that. Okay, so there's our scatter plot. We described it. Now, I want you to see what a residual plot looks like, again, with some data that's definitely not linear, right? So we're going to do the lin-reg. I want to create an equation. So I can't look at the residuals right now. The residuals in my list are from the hamburger problem. So it's not even going to have the same number of data values. I need to go stat calc down to 8, list 1, list 2. And your calculator will fit a line to anything you ask it to. So it'll be interesting to see what that line looks like as well. Okay, we can see that we have a pretty low R squared. It's only 25%. And our correlation is only 0.5. First, look at the graph. See the line that it created for that? Doesn't do a very good job, does it? Then, let's go to our stat plot. And let's change my Y list to resid. Second list, up, resid. Make sure you do the lin-reg with me first, otherwise it's not going to work. It's going to say dimensions mismatch because you're not going to have the right number of data values in your residual plot. Look at this residual plot, okay? It definitely is not randomly scattered with no pattern, right? It's curved just like our scatter plot. And so this is where you would say both that a linear model is not appropriate because our scatter plot has a clear curve and the residual plot is not randomly scattered and it has a clear pattern as well. Okay, so I wanted you to see like a lot of the residual plots we've looked at are appropriate, right? It's good to kind of look at some that aren't and kind of get that to see that it actually does happen where you're like, oh wait, no, that's not appropriate. Okay. So when I look at my scatter plot, I see 3 clear patterns. If I trace it, I would either stop at 72 or 76. Either one is okay, right? So we're going to use at least from 1950 to let's just include 1976. So here's a way to do that without having to retype all of that data. I want to create a regression model. This isn't going to be a very good predictor. So I'm going to make a new list. And if I go up to highlight list 3, I can just say copy list 1. I can just hit list 1, second list 1. Highlight list 4, second list 2. And it copies it. And then we said we wanted to use up to 1976, right? So I'm just going to delete everything after 1976.
How did you highlight it again?
Just use your arrow to go up to the list name, L4, L3, and then second, whatever list you want to copy into it. Now I have a list of just the data from 50 to 76. Create this new model and predict the size of the 1969 graduating class.
I didn't delete that one thing.
I just delete. Yeah, you just hit delete. So create the model and make your prediction.
Should I delete everything below?
I gotta try my
Yep. Now, when I do this linreg, it might be interesting to leave the entire scatter plot the way it is and put the new line on it to see how well it fits those points. Instead of erasing it and doing a new scatter plot with just list 3 and 4, let's leave all the data. Okay. What?
Do we turn two of the graphs on?
No, because we have all the data in one graph, right? But we're going to use, say, Y2 instead of Y1 when we do our linreg. So we can see both the original regression line and the new one of just that data. Okay, so I'm going to walk you through it because I'm getting confused looks. So I'm going to go stat calc 8. I hit the wrong button.
It's going to be list 3 and 4.
I'm doing my list 3 and list 4. And when it says store regression equation, vars, y vars function, I'm going to hit Y2. That's going to keep the first line that we made for all the data on the graph as well, so we can see a difference. Okay, so hit calculate. There's my new equation. And then watch what happens when I hit graph. That's the first regression line of all the data. And then the red line, how well did it fit our new subset? The red line?
Yeah, it looks like I can't see.
Do we not? It looks like that red line fits it really well.
Yes.
The blue line was the first regression of all the data together. So sometimes we need to break the data up into subsets and create separate models so we can make predictions that are going to be more accurate. So your new model,
That's why, because you don't have it because you took it out.
No, I didn't. It's right here.
Oh, look, guys, look. He's disconnected.
is number
Not the lines.
Now you messed it up.
number grad hat, negative 522.34 plus 14.32 years since 1900. If you put the year 1950 and 1952 in your calculator, then your x variable is not years since 1900, it's just year. Now you can plug in 69 if you used years since 1900 or 1969 to make your prediction. Can we get the residual plot for this subset? Okay, I did the linear regression on the subset of data, the smaller set of data, right? That's what a subset is. I have all the data, I'm taking part of it and doing a new regression on it. So I want to look at the residual plot. Did it model it better? Obviously from the scatter plot, it looks way better, right? Looking at our scatter plot again, that's the original line if I include all the data. And the red line is the new one of just the subset, and it looks like it fits it really well. The reason we chose Y2 was because this is where the calculator in the Y equals menu graphs lines. Lines, parabolas, whatever you want to graph. So if I tell it Y1 over and over and over again, I'm replacing whatever equation was in the Y1. So because I wanted both equations on my graph, I chose to put it into Y2. That way I can see both lines on my scatter plot. Okay, if I wanted to put a third line on my scatter plot, I can put it into Y3. I can put up to 10 different equations into Y equals and it can graph them all. Okay, so let's look at our scatter plot or our residual plot. I'm gonna turn this on, that's list 3. Go to my residual list. Zoom 9. Much better, right?
Yes.
Our residual plot now shows that this linear model is appropriate. There's no pattern, there's random scatter, and there's consistent spread. Okay, so that's how we can take data that maybe isn't useful for a linear model and divide it up into subsets and get a useful model. I changed my Y-list to resid after I already did the linreg.
Hey, I see the same thing.
In your stat plot, you're changing your Y-list to resid.
I mashed this
Let's go to your no, like
Was it right? She could have made it. But she was.
Okay, I just didn't use it. I'll do it. I'm trying to find a okay, let's just go up.
Because you're telling me list 1, which is all the data, but the residual only has our subset. You need to have that list 3. Okay. Yes. No, I did L3 and Y list is yes. Okay.
Why you gotta do that? I didn't say
You're right.
All the data, but you're residually using a subset. Right. So what you did was you I wanted to see so I went to the whole set plot, this one was 2, and then put the lines for the sets. You changed the scatter plot, I changed the scatter plot. Yes. Remember, this is next chapter. You're not gonna have to make subsets on the test. Right? But you still have to be able to create a residual plot, a regression model, look at the scatter plot, and change it. Yep. There's another one over by the phone. All right. So tonight's homework is on chapter 8, but it's not due till Wednesday. And I do not actually see you at all on Wednesday. Wednesday's called kickoff day. 11th graders are taking the PSAT. 12th graders are doing college applications on the ASVAB. And you're going to go only to the period. You're not an avid, you're signed up for the ASVAB
unless you
But what if you're an avid but you want to see the ads that you don't know if they're in there?
it's on your average measure. Might as well get it done.
I already took my ads up once last year. I scored an 80. I want to again. I did. See if I'm getting higher.